So topic 7-1, similar polygons. So similar polygons is defined as polygons with same shape but different sizes. Now this is a little bit different than congruent because, well, actually it's not a little bit different. It's a lot different than congruent because congruent is defined as same shape, same size. So polygons with the same shape but different sizes are similar polygons. Now, if two polygons are similar, there are two things that are true that help us to determine this. So number one, the corresponding angles are congruent. And number two, the corresponding sides are proportional. So if you think about it, this definition, the definition of similar kind of goes right along with this. Corresponding angles, congruent, that's how we're going to get the same shape, okay? But the sides being proportional, that's how we're going to get the different size, okay? Okay, so in example 1, we want to use the figures below to answer the questions that follow. And so all we're saying here in this first example is which angle is congruent to, so for example, in triangle ABC, angle A is congruent to which part in triangle XYZ. And so angle A is going to be congruent to angle X because they're in the same position. Angle B is going to be congruent to angle Y, here again, because they're in the same position. And then angle C is going to be congruent to angle Z, and here again, because they're in the same position. So angle C congruent to angle Z, okay? All right, now, line segment BC. So here's line segment BC. It is in the ratio of line segment YZ, or it corresponds to, that's what I'm going to say. I'm going to say it corresponds to YZ. So BC corresponds to YZ, really and truly, because they're just in the same position. Line segment AB will correspond to line segment XY, again, because they're in the same position. Okay, and then last one, line segment CA will correspond to line segment XZ, here again, because they're in the same position. So line segment CX, okay. So in problem number 2, if triangle LMN is similar to triangle RST, then what must be true? Well, angle L will be congruent to angle R, angle M will be congruent to angle S, and angle N will be congruent to angle T. Now, maybe an easier way for you to see this is if you do this, L, M, N, R, S, T. And so there's kind of a one-to-one relationship here. L goes with R, M goes with S, N goes with T. And so about the angles, I know that angle L is congruent to angle R. I know that angle M is congruent to angle S. And I know angle N is congruent to angle T. All right, so what do I know about the sides? Well, I know the first two letters have to match the first two letters. LM has to match RS. So line segment LM is congruent to, oh, sorry, not congruent. Line segment LM corresponds to, okay, so we're just going to use a colon. So line segment LM corresponds to line segment RS. Line segment MN corresponds to line segment ST, and then line segment LN corresponds to line segment RT. Okay. Make sure I didn't leave anything out. Okay. So a very important term to know when talking about similar polygons is included. An angle is said to be included between two sides, and a side is said to be included between two angles. So use the figure below to answer the questions that follow. So name the angle included between AM and MC. So here's AM, here's MC. We're naming an angle. Where do those two segments meet? Which angle do they meet? And that's angle M. Okay. So name the side included between angle A and angle M. Well, the side that connects angle A and angle M is line segment AM. Okay. And then name the side included between angle A and C. Well, we already know where angle A is, so here's angle C. And so that's going to be that side there, so line segment AC. Okay. Okay, so the next thing we're going to talk about is something called the common ratio. And the common ratio is the ratio of the lengths of two corresponding sides. So use the similar figures below to answer the questions that follow. So what is the common ratio of quadrilateral ABCD to quadrilateral EFGH above? Okay. And so we're going from ABCD, so we're going from the big quadrilateral to the little quadrilateral. And so I'm just going to kind of look at the sides that correspond. So I know that AB corresponds to EF. I know that AD corresponds to EH. I know that DG corresponds to DC corresponds to HG. And I know that FG corresponds to BC. All right, so what is the common ratio of quadrilateral ABCD to EFGH? Well, I know that 5, and because we're doing ABCD, I want to put the big number on top. I know that 5 goes with 2.5. I know that 10 goes with 5. I know that 8 goes with 4, and I know that 6 corresponds to 3. Now, if I simplify each one of these fractions, each one of these simplify to 2, and so my common ratio is 2. Okay? Now, if it asked me for the common ratio of EFGH to ABCD, that common ratio would be 1/2. But here, the common ratio is equal to 2. Okay? All right, show that the ratio of the perimeters is the same as the common ratio. And so how do we find perimeter? Well, we just add up the sides. So I'm going to add up the perimeter of ABCD. And so that's 10, 8, 6, and 5. So 10 plus 8 plus 6 plus 5. So that's 18, 6, 24. So that's 29. All right. And then if I find the perimeter of the smaller polygon, EFGH, well, that's 2.5 plus 5 plus 4 plus 3. So 7 plus 5 plus 12, or 7 plus 5 is 12 plus 2.5 is 14.5. All right, so now if I do 29 divided by 14.5, well, guess what? That's equal to 2. And so what we learn here is this, the ratio of the perimeters, so you might want to highlight this, the ratio of the perimeters is the same as the common ratio. Okay, That's always true. The ratio of the perimeters always equals the common ratio. Okay, so what is the common ratio of quadrilateral EFGH to quadrilateral ABCD in example 6? Well, we've already kind of talked about this. All we would do is we would flip these fractions upside down. And so we would get 2.5 over 5, and we would get 5 over 10, and we would get 4 over 8, and we would get 3 over 6, and all of these fractions clearly simplify to a half. And so the common ratio of EFGH to ABCD is a half.